The moment your heart stops, you are not dead. Not yet. What happens in the next 5 minutes is one of the most contested, most documented, and most unsettling questions in all of modern neuroscience, and the answer most scientists have settled on is deeply uncomfortable. Death is not a moment, it's a process, and consciousness does not go when your heart does. Let's start with what actually happens at second zero. Your heart stops beating, blood pressure drops to nothing. Oxygenated blood is no longer moving through your body, but your cells don't know that yet. They're still running on whatever oxygen is left. Your brain, which consumes more oxygen than any other organ in your body, has enough reserves to keep functioning for roughly 4 to 6 minutes before the damage becomes irreversible. 4 to 6 minutes. That's not nothing. That's a significant window, and what happens inside that window is where things get strange. Within the first 30 seconds, blood oxygen levels in the brain begin to fall sharply. You lose consciousness. If someone is watching, this is the moment they see you go still, eyes fixed, no response. From the outside, it looks like the end. From the inside, according to the data, it may be anything but. Because here's what researchers started noticing in the early 2000s. Patients who were resuscitated after cardiac arrest, patients who were clinically dead by every standard measure, started coming back with memories, not vague impressions, specific, detailed, structured experiences. A 2014 study called AWARE, led by Dr. Sam Parnia at New York University, monitored over 2,000 cardiac arrest survivors across 15 hospitals in the US and UK. Roughly 40% of those who survived reported some form of awareness during the period when they were clinically dead. Not before, not after, during. One patient correctly described the actions of the resuscitation team in the room while he had no heartbeat and no measurable brain activity. He described the specific sounds, the sequence of events, the position of people in the room, none of which he should have been able to access. Now, here's where the science splits, because neurologists will tell you that conscious experience requires active brain function, and active brain function requires oxygen, so awareness during cardiac arrest should be neurologically impossible, and yet the reports keep coming, documented across cultures, across age groups, across people who had no prior belief in any kind of afterlife. The patterns are too consistent to dismiss as noise. In 2023, researchers at the University of Michigan, the same team that had previously documented gamma-wave surges in dying rats, published a study of 4 comatose patients whose life support was withdrawn. In 2 of the patients, the EEG showed a dramatic surge of gamma-wave activity at the moment of cardiac arrest. The same high-frequency brainwaves associated with conscious awareness, dreaming, and memory retrieval. The same pattern seen in the rat studies now appearing in humans at the exact moment of death. This is what makes the first 5 minutes so strange. The body is shutting down, but the brain may be doing something completely different, not winding down, in some cases briefly accelerating. So what is actually dying and in what order? Here's the sequence that science has mapped so far. At minute 1, you lose consciousness. At minute 2, the brainstem begins to lose function. Reflexes disappear, pupils fix and dilate. At minute 3 to 4, brain cells begin dying from oxygen deprivation, starting in the most metabolically active regions, including the hippocampus, the structure most critical for memory. At minute 5, without intervention, the damage becomes extensive enough that even successful resuscitation will likely result in permanent neurological injury. This is the hard boundary doctors use: 5 minutes. But here's the problem with that timeline. It assumes the brain is simply running out of fuel and going dark. The gamma wave data suggests something else is happening simultaneously. As the oxygen supply drops and normal brain function begins to fail, something appears to briefly reorganize. A surge, a final coordinated firing across regions normally associated with waking consciousness and memory retrieval. Nobody has been able to explain why. One hypothesis is that it's purely mechanical, a last chaotic discharge as inhibitory neurons fail and the brain briefly loses the brakes on its own activity. Another is that it's something more structured, a genuine final moment of heightened experience. The data doesn't yet tell us which. What it does tell us is this: the boundary between life and death is not a wall, it's a corridor, and the brain appears to be active inside that corridor in ways we didn't expect and still don't fully understand. There's one more piece that most people don't know. In 2022, a study published in the Proceedings of the National Academy of Sciences reviewed the cardiac arrest data and concluded that some of the experiences reported by resuscitated patients, the life review, the sense of clarity, the perception of the environment despite being unconscious, may be occurring in that final surge window, not before death, not after resuscitation, in the gap itself. Which raises the question that science is not yet equipped to answer. If your brain is producing structured, organized, conscious-level activity in the minutes after your heart stops, at what point does the experience end? Is it when the last neuron fires, when the last coherent pattern collapses? Or is there a moment somewhere in that 5-minute window that feels from the inside like something? The honest answer is we don't know. The data gives us the electrical signature of something happening. It does not give us access to what that something is like. What we do know is that the first 5 minutes after your heart stops are not empty, not silent, not nothing. Whatever death is, it is not the instant your heart stops beating. And whatever consciousness is, it does not go quietly. It might not go at all until the very last signal finally fades.